theorems in geometry. That helps students to develop thinking and reasoning powers. Let us see the same theorem, how to prove or how to help students to prove on their own. What is the theorem? If a perpendicular is drawn from the center of the circle to its chord, bisect the chord. The fundamental aspect is, let the student understand the statement first. For understanding the statement, the student should read the statement or listen to the statement number of times. What is the statement? If a perpendicular is drawn from where? From the center of the circle to where? To its chord, then what happens? It bisects the chord. So in any statement there will be two parts. One is, if a perpendicular is drawn from the center of the circle to its chord, then it bisects the chord. Right? So in any theorem statement there will be two parts. One is given. What is given? The perpendicular is drawn from the center of the circle to its chord. What is that we have to prove? That perpendicular bisects the chord. So this, the student should be able to understand these two parts in the given statement. What is given and what is that we have to prove? If the students are clear about these two parts in a statement, in a theorem, then definitely they will be able to suggest the suitable figure to solve the problem. Sorry, to solve the theorem, prove the theorem. So for proving this theorem, we need a figure. We need to take a figure and we need to test or prove it. So what is the figure that we need? According to the data that is given in the statement, we need to select the figure. It is about drawing the perpendicular from the center of the circle to its chord. Then naturally, what is the figure that we need? We need a circle, no doubt. We need a circle with the center of the circle O. Right? This is the circle we need, right? And also we need to take a chord. Let us name it as AB. What else is given? The perpendicular is drawn, that is also given. Right? Let me name it as M, this is O. This is the statement in the figural form, in fact. What is that we have to prove? We have to prove that that perpendicular drawn from the center to its chord bisects the chord. That is what we have to prove. So, bisects means this OM divides this AB into two equal parts. Means AM and MB should be equal. So, from this we can easily elicit what is given data, what is to be proved, what is given. Now we have already written what is given and what is to be proved we have already written. Now it is clear. Now the construction. What is that we have to prove? We have to prove that AM is equal to MB. This is very crucial stage in proving theorems. Because student himself or herself should decide what is the required construction for proving this particular theorem. Here, the teacher has to discuss with the students, analyze, help the students to think in different ways. When suppose these are the two line segments or two sides. When two sides will be equal? Probable situations. If they are the opposite sides of a rectangle, equal. In this situation, can you find two figures with having rectangles? No. In a square also it is possible. Adjacent sides are equal, opposite sides are equal. We cannot form squares also. And in a triangle, you might have studied in our previous class. You have studied in an isosceles triangle. In congruent triangles, the corresponding sides are equal. In congruent triangles, the corresponding sides are equal. So, if we want to prove that AM is equal to MB, it is enough if we can prove that there are two triangles which are congruent. Also, the two triangles are having AM and MB as the sides of the triangles. Then how to form two triangles here? Then that should be congruent and the sides should be equal. I mean, these two should be the sides